wasn't recording. Okay.
Or would it be something that multiplies by itself to get to that number too?
Right. We've made lists of perfect squares, right? Like 1 squared is what? 1. So 1's a perfect square. 2 squared is, so 4 is a perfect square, right? 3 squared is,
9.
what's the square root of 9?
3.
3. The square root of 9 is 3. It keeps doing that. Okay. And you also know, actually, that when you take the square root, how many units are there at?
2.
The positive and negative, right? So square root of 9 is really plus or minus 3, right? You do 1 over the square, you get 9. A lot of the times, we're just going to work with what's called the principal square root, which is the positive one, right? So take a look at these here. Square root of 25 there. Is 25 a perfect square? What is its square root? And we're talking about the principal, right? So we're not going to worry about plus or minus 5, right? So it's just 5. Let's keep going here. Square root of 9. 3. Square root of 100. Was there a hesitation square root of 100?
No.
Okay, I didn't hear you say anything. What's square root of 0? What's square root of 1/4? 1/2. Right? Does that confuse you, right? Square root of 1 is what? Square root of 4 is? Okay, what's the square root of 64 over 9?
8/3.
8 over 3, right? So this is so hard, is it? Okay. Now what do they want us to do? Yeah, okay. Now they want 2 squares, positive and negative, right? So give all square roots of the following number, right? So they should put in here, what's the square root of 4? Now it's not the principal. Plus or minus 2, right? It's 2 or negative 2. What's the square root of 36? Come on. Plus or minus 6. What's the square root of 1/16? Plus or minus 1/4. Right? Okay. Exercise 3, we have a square root function. F of x equal, what is that? We do function. In order of operation, right? Okay. So the square root thing is kind of like parentheses. You can work inside of that first, right? So f of x equals square root of x plus 3. They want the value of f of 46. So you know what to do, right? Square root of 46 plus 3. F of 46 equals the square root of what? 49. What is the square root of 49? Just the principal square root. Equals 7, right? You know it's plus or minus 7, but again, we're just dealing with the principal. Okay, so now this is an interesting little property of square roots, okay? So they're going to explore. The square root of 4 times the square root of 9. Let's take the square root of 4 first. What is that? 2 times 3, which equals 6. Okay. Now look how they have this. Look how they had it here, separated into 2 different square roots. And now they're multiplying both of them and then taking the square root. So that would be the square root of what? 36. And what's the square root of 36? 6. You see anything that's equivalent here? Well, those, right? Let's look at C. Square root of 4 is what? Times what? 5, which is 10. Now look what they do. So that's the square root of what? 100. And what's the square root of 100? 10. Okay. So are you seeing a little pattern or property here? You multiply square roots, the same as taking the square root, multiplying. And the top of the next page, they give you this property, but I'm going to expand on it and enhance it a little bit. So from what we just did, you can see that if you take the square root of A times the square root of B, isn't that the same as the square root of A times B? Okay? And also, equal signs go both ways, right? So if I have the square root of A times B, I can break that up into 2 separate square roots with multiplying, right? Okay, let's do this real quick. Let's see the note, but the notes page is already kind of there for you. We're on page 9.
Oh, this looks horrible.
No, this Is this right here not the same thing you just saw? Okay, no big deal. So, and also equal signs go both ways, right? So if you have this, you can split it up into that. This also works with division. Everybody see this? Not just multiplication, right? Square root of A over square root of B is the same as the square root of A over B. And again, you can split it up and go the other way. Now, be very careful. This property does not work with addition and subtraction. Okay, you see this here? Square root of A plus the square root of B is not the square root of A plus B, or minus. Not. You got that? Everybody looking up here? You see this? The thing, right? This is, you see that not equal to sign there? This only works with the multiplication and division, right? So for example, square root of 4 times the square root of 3 using this property would be what? Square root of 12. Why did you say 12? I heard people say 12. Is this a 12? No, it is not. That's a square root of 12. It's a completely different number, right? All right, over here, using this, the division version of this property. Square root of 50 over square root of 2 is the square root of 50 over 2. What's the square root of, what's 50 over 2? And what's the square root of 25? Okay. So again, you need to know your perfect squares, right? Because we're going to need to be able to identify perfect squares when we go to simplify these things, right? So we're going to make a list of them. We've kind of done this before. We didn't do quite as many, right? So let's just fill in the blanks here. 1 squared is what? 1. So everything you're writing, listen carefully, what you're writing in the blank is the perfect square, not the thing that's on the page, your meeting square, right? Okay? 2 squared is, so just keep filling these out.
17, 25, 36, 21, 64, 84,
Yeah, keep going. 100, 21, 144. That's it. Come on. 169. Geez, if you had a calculator, it might be helpful too.
I'll get up in
14 squared, 196, 225,
Wait, now you're going to
256. I'll let you fill them out.
289.
289.
You see what's
Later.
324.
324. 19 squared,
361.
361. And hopefully you just know that that's 400. Right? To be clear, everything that you wrote in the blank is the perfect square, not the number you squared to get it, right? And they're perfect squares because when you take the square root, what do you get? A whole number, right? So for example, 121 is it a perfect square? So square root of 121, not 11 squared, just 11, right? The square root of 144 is what? 12, square root of 36. They're perfect. Look how the square roots come out. Nice whole numbers. Okay? So you need to be familiar with these perfect squares, right? So you can spot them when you need them. Okay, so now that we kind of know what perfect squares are, let's look at putting things in what's called simplest radical form. And by the way, the radical is that square root symbol. Okay? It's called radical. Okay, simplest radical form. And the thing underneath it, the number is called the radicand. Okay? Anyway, so simplest. So what we do is, you know the property up here? Like if I have this here, right? Some number in there, maybe one of the factors of that number is a perfect square, which you can take the square root of and get a nice whole number, right?
Yeah.
So let's look at an example here. Take a look at the square root of 80. Of your list of perfect squares, does 80 have any perfect square factors? Well, what you should do is on your calculator, when you're learning this, is put in 80 and start dividing by these perfect squares and see which one goes into it nice and easily. I wouldn't bother dividing by 1, but divide it by 4, divide it by 16, by 36, right? Go ahead and find one.
64.
Okay, so 4, also, right?
Yeah.
But what we want is the biggest perfect square, right? So really what you should do, everybody listen, look up here. Instead of working up the list here, dividing 80 by these, yeah, I mean, obviously, 81, 64 is not going to go in evenly, right? 36, pretty sure it's not, right? But you can check it. Huh? 20 is not a perfect square. It's got to be a perfect square. There's 20 in this list? No. But 16. So what is 80 divided by 16? 5. So I can rewrite the square root of 80 as the square root of 16 times the square root of 5. Really, it's the square root like this. 16 times 5, right? Times 5. But then by that property, I can split that up, can I? Okay. 16 is a perfect square, right? What's the square root of it?
4.
So that 16 becomes a 4, and the square root of 5 is not a perfect square, so we just leave it under there. Okay? So that ends up square root of 80 in simplest radical form is the square root of 4. Or 4 times the square root of 5. Okay? Take a look at the square root of 52. What's the biggest perfect square factor of 52? Start dividing by, and they got it there, right? Probably find it. So 52 divided by 4 is what? Right? So isn't 52 equivalent to 4 times 13? So it's a square root of 4 times the square root of 13, right? But there's that perfect square. Comes out as a whole number. Square root of 4 comes out as a 2 times the square root of 13. We leave that under there because it's not, it'd be an infinite decimal that, you know, isn't irrational, right? Now take a look at this one. It's a little different, right? We're using that property going the other way, right? Neither 2 or 14 are perfect squares, are they? No, and they don't have any perfect square factors. So why don't we multiply the 2 and the 14 and get the square root of 28? Now it's just like one of these. Does 28 have any perfect square factors? 4, right? 4 times what? So the square root of 28 is equivalent to the square root of 4 times the square root of 7. What's the square root of 4? And times the square root of 7. That's simplest radical form. It's not that hard. You know how to do it, though. So square root of 54. I'll walk you through this one, okay? What's the biggest perfect square factor of 54? Start dividing it by perfect squares that you have up there. Your calculator there. Unless you can do it in your head. Okay, is that the biggest of the, because you want the biggest factors. You guessing what?
It's the biggest.
So 9 times what?
4.
So square root of 54 is the square root of what? 9 times?
6.
And I'll do it right?
I thought it was at 4.
But I can break this up into what? The square root of 9 times the square root of 6. And what is the square root of 9?
3.
So what's my answer here?
3. So then the square root of 9.
Not and then times the square root of 6. And there you go. Okay? If you guys try that with the square root of 180 on your own. So the biggest perfect square factor was what?
36.
So I'm just going to skip that little intermediate. So square root of 36 times the square root of what?
5.
5. And what's the square root of 36?
6.
6. Square root of 5. It's not that hard, right? Okay. Now number 3 here is like this one up here. I mean, are 5 and 10 perfect squares, or do they have perfect square factors? So multiply them. You mean square root of 50? Okay. Now, the biggest perfect square factor of 50? That should be easy. 10 is not a perfect square. Why do kids always shout out non-perfect squares? You got a list of them up here.
25.
25, right? Times what?
2.
So how do I rewrite it?
I don't know.
Square root of 25 times square root of 2, which becomes 5. 5 times the square root of 2, simplest radical form. You might see this abbreviated SRF, by the way. SRF. Sierra Romeo Foxtrot. Okay, do number 4. Ooh,
So you gotta.
what's the square root of 16? Thought I saw it. Okay, so what's your answer now? Not squared by 4 times the square root of, you had 3 there. Didn't you have a 3 there? What? Now you do. Okay. So I'll multiply and get the square root of 48. The biggest perfect square factor of 48 is 16, right? Times what? And the square root of 16 is 4 times the square root of 3. All right, number 5, a little bit different. Yep. You know, by the commutative property, you can multiply in any order, right? Okay. Oh, by the way, I cannot do 2 times 5 and call it the square root of 10. You understand that, right? Well, yeah, right. So you can't multiply into the square root like that, right? So we can do 2 times 4, which is what? 8 times the square root of what? What's 5 times 15? Those I can multiply together.
75.
8 times the square root of 75, right? Anybody confused by that? Okay. Again, I can't do 4 times 15, right? Because that's not a 15, is it? What is it? Square root of 15. Okay, so I can't multiply the 4 and the 15. Am I recording? Yes, I am. Okay. Now that 8 just stays there for a little while, right? Now the square root of 75. Let's simplify that. So this is going to equal 8 times, let's just do this. What's the biggest perfect square factor of 75? That should be pretty easy. 3 is not a perfect square. 25, isn't it? You look at your list of perfects. 25 times what? So it's the square root of 25 times the square root of 3. Now what's the square root of 25? 8 times 5 times the square root of 3. Now we take care of that 8. What's 8 times 5? So nothing too nuts there, right? That 8 just kind of rolled along to the end. Use it. Can you get the idea here? Okay. No, you see the rest of the page here. Okay. Now, down here, one rule in mathematics is you are not allowed to have a radical square root in the denominator of a fraction. The denominator is the bottom one, right? Right? Because it's irrational, right? You know what an irrational number is, yeah? The decimal that has, well, one of the consequences of being irrational is the decimal goes on forever. That's not, they talk about that's the definition of it, right? That's not actually the definition, right? It's a number that can be found by dividing 252. It's like, it's a consequence of being irrational that has a decimal that goes on infinitely without repeating. Got it? Hey, can you divide by something that goes on infinitely?
No.
It's like, you don't know how, like, where you, right? You can't divide by a number like that. So, in math, you cannot have a square root in the bottom of a fraction. So it's dividing by something like that, right? Your calculator could do it, right? But like in the language of math, you really can't. Your calculator goes through an algorithm and it gets decimal approximations, right? So here's what you do. So let's take the square root of 35 over 15, right? Now, one thing you can do is put it in lowest terms to help yourself. You don't have to, right? But it helps. I can divide top and bottom by 5, can I? And get what? Square root of 7/3, right? Now I use the property at the top of the page to do what? See the property at the top of the page? Right? I can split it up and square root of 7 over the square root of 3. There's my problem. I have a square root in the bottom. Can't have that, right? So here's how we fix it. We multiply that whole fraction by 1. What? Let me ask you a question. What's any number divided by itself? 1. What's 2 divided by 2? What is 90 divided by 90? What is squirrel divided by squirrel? 1. Okay? 1. Anything divided by itself is 1. So we're going to multiply by 1, but a particular form of 1. Right? No. Take a look at here. What's the square root of 3 divided by the square root of 3? 1. Aha. Now, my other question is, if I multiply something by 1, do I change the value of it? No. So if you agree that this thing here is a 1 and I'm multiplying by it, am I changing the value of the original fraction? No. I'm going to change the look of it though, right? And you know how to multiply fractions. You multiply across the top and across the bottom, right? So what is square root of 7 times the square root of 3? Square root of 21. What is the square root of 3 times the square root of 3? You all understand it's 3, right? There's 2 ways to look at it. First of all, you know that squaring and square root undo each other, right?
Yeah.
Right, like addition undoes subtraction. Right? So take the square root of 3 times the square root of 3, right? Isn't that like squaring it?
Yeah.
And didn't you just tell me that squaring undoes square root?
Yeah.
So what's left? 3. Or you could look at it this way. Or use that property at the top of the page. Square root of 3 times the square root of 3 is actually the square root of what? 9, which is what? 3. In either case, the square root's gone in the bottom, right? So we multiply. What if it was the square root of 5 on the bottom? What would we multiply by here? No. Why 5? How about the square root of 5 over the square root of 5? Those are different numbers. They need precision, right? Okay, let's try this one here. You can put it in lowest terms. You don't have to. But do it. It's 1/2. Divide them both by 3 or by 6. So square. Hang on, we're dancing here. So square root of 1/2. Now let's use our property up there. It'd be what? Square root of 1 over the square root of 2, right?
Yeah.
We know what the square root of 1 is, don't we?
Yeah.
Okay, let's just do that. So we'll call this 1 over the square root of 2. Okay, what's the problem here? The square root in the denominator. What are we going to multiply by? We're going to multiply by 1, which in this case, this form of 1. Square root of what? What is it? Square root of 2 over 2? Is that what you meant to say? Say what you meant to say. 2 over 2, you said. Oh, square root of 2. Yeah, that's exactly right.
I was talking about one big square root sign. No, sorry.
Well, that's not what we did over here.
Yeah.
Okay. What do we have on top? What is 1 times the square root of 2?
1.
1 times the square root of 2 is the square root of 2 over what? 2. This is called rationalizing the denominator, because now we have a rational number in the denominator, in the bottom. Okay? 2 is not, square root of 2 is irrational. We got rid of it. Did we change the value of this fraction at all? Because we only multiplied by what? 1. Particular form of it, right? All right. Yeah. This is, yeah. Okay. Now number 2. 5 by 2.
Then you get 4.
Why would I by 2.
Yeah.
What should I multiply by here? Huh? What form of 1? There we go. Now we're getting it. Square root of 2 over the square root of 2. Okay, multiply across the top. Are you telling, did you just do 8 times 2? I don't even see a 2 up there. Do you? I see a square root of 2. 8 times the square root of 2. I can't multiply that 8 in there, right? Over what? 2. Have we rationalized it? Okay. But we can simplify it even further, can't we? How? This isn't new. Do you see 8 divided by 2? Okay. So it's just 4 square roots of 2. Okay? Take this last one here. Ah, we got that 5 out there, right? So maybe that's one that's just going to go on for the ride, right? To the end. So let's do this. 5 times the square root of 6 over the square root of 3. What do I want to multiply this by to rationalize the denominator?
1.
What form of 1?
3 over 3.
Go ahead, say it. Square root of 3 over the square root of 3, right?
Yeah.
Now the 5 can't multiply into that square root.
So,
But can I do the square root of 6 times the square root of 3?
yeah.
Which is actually the square root of what? What? It's 5 times the square root of 18 over what? 3. But now, you see that square root of 18?
So you multiply the 5 into it? 5 times 3.
Wow.
Yeah.
I just got done saying 183 times you can't multiply into the square root like that.
Yeah. I didn't even say
And
that.
you got it, and then she said it. No, she gets it, and then you said it again. Wow. Are there any perfect square factors of 18 like we did up here? What? 3 is not a perfect square.
9.
The numbers you wrote are the perfect square. Look and tell me.
No.
It comes from 3, so 9, right?
Yeah.
So 9 times what?
5.
So 5 times the square root of 9 times what?
3.
9 times 3 is 18.
45. What? My perfect square, but that's 81. That's 18. 6.
2.
2.
Ay, ay,
I
ay.
thought we were dividing 18 by 3. Oh.
I can't divide 18 by 3. I can't multiply anything or divide into it.
I got it. Not really, but I got it.
The square root is it's like a padlock, right? It's locked in there, right? You can't just multiply stuff unless you got another square, and then you can merge, right? You multiply. Okay, what's the square root of 9?
3.
So it's 5 times 3 times the square root of 2 over 3. I could do 5 times 3, but does something cancel here?
Yeah. What?
What cancels?
5,
So what am I left with?
3.
5 times the square root of 2? Is it 3? Cancel. Yeah, you've been doing a good job.
So,
That one.
no, I was reading off what he was writing.
Talking to.
And I was writing, he said, I'm just saying random things. Sound like you're saying random things. Oh, okay. 5.
Okay. So if you get the gist of this, let's go back now. Kind of enhance what they gave us. All right, so exercise 5. Hopefully we know what to do with this here, the square root of 2 times the square root of 8. Can I use that one property and write it as 1 square root? Can I?
Yeah, multiply it.
Right, so it'd be the square root of what then? 16. That's nice. Let me ask a stupid question. What's the biggest perfect square factor of 16? What's the biggest perfect square factor of 16 from your list of perfect squares there? 6 is not a perfect square. 16 times 1, right? Well, anyway, it's a perfect square, and its square root is 4, right? All right. Part B. You say we multiply those and make one square root. So not 36. Square root of 36. Yeah, what's the biggest perfect square factor of 36? Oh, it's 36 times 1. But anyway. So, what? 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 Okay. Something. All right. This would be the square root of what?
100.
Okay. Which is 10. They really kept it kind of simple here. All right. Now down here. This is going to, huh? Can you just do what?
Half
Half of what?
of your bigger number.
Half? You mean the square root? You're saying it's the same as dividing by 2? I thought square root undid squaring. Is squaring the same as multiplying by 2? No.
No, but like 8, that one came out to 4, so you just divide that by 2.
That's just a cosmic coinky dink. That is all that is. Yeah, that's just coincidence. No, you're looking for a pattern that's really not there. I'm glad to see that you've recognized the pattern, but now I have to go change this for the rest of time because some other kid's going to see a pattern and think that that's how it works. No, it doesn't. Okay, that's coinky dink. I gave you credit for thinking. All right, now we got one that's a little more like we did on the page, right? Square root of 18. Which of these? What do I mean by these? I don't know. Okay. Anyway, square root of 18. Let's just skip over to part B because we've already done this. Square root of 18. What is the biggest perfect square factor of 18?
18.
Okay, is 18 one of the numbers you wrote on that one? So stop telling me numbers that you didn't write on that page. We just squared a bunch of. Okay, 9 times what? So I can rewrite this as what? Square root of 9 times the square root of 2, which equals what?
3 times.
There we go. 3 times the square root of 2. Simplest radical form, SRF. All right? So let's try these.
I thought we couldn't do negatives.
What do you mean? Are you taking the square root of a negative?
No, it's negative.
Are you taking the square root of a negative number here?
Yeah.
What's under the square root sign? A positive number.
Yeah,
So
but
what's the
the
problem?
line on the outside?
That's a negative sign.
What's a negative sign?
Order of operation, right? Parentheses, which is square, it's like a parentheses, right? Get to that in a minute. So just do these like we did on the other page. So I can rewrite this as what? No. Square root of 4 times the square root of 2, which equals what? 2 times the square root of 2. Okay. Now you move on and do B and C on your own. Okay, what's the answer to B in simplest radical form?
3 is square root of 5.
And you put the word and in there?
3 times square root of 5.
Okay. Because you split this up into what?
9.
No, you didn't.
Square root of 5, square root of 9. Square root of
I like to lead with the perfect square first. Right? Times square root of 5. And then that's 3 square root of 5, right? What'd you get for C?
4. 9 is square root of 3.
4 times the square root of 3. Because you split this up into what? Square 16 times, no, square root of 3. And what's square root of 16?
4.
So 4 times the square root of 3. All right. Anybody do D?
No.
Why is that? You're not taking the square root of a negative there, right? The negative's outside.
Yeah, but why is there a negative out there?
What's the difference to you?
What's the point?
Why not? What's the point of not having it there? All right, then it answer me this. What's the point of having a positive out in front of that one?
Makes it easier.
How's it any easier? Listen. Right,
I did it.
equals negative
Square root of 25.
square root of 25
Square root of
times the square root of 3, which equals what?
5.
What?
Negative.
Negative
5.
5 times the square root of 3. Man, was that any harder than any of the other ones?
Yeah. I don't know, 'cause why did that negative go to the 5?
Because it's negative times the square root of 25. And the square root of 25 is 5. So it's negative 5. Why can't there be? There can be negative anythings. It could be negative u.
There can be negative anything because it can be negative lengths.
Negative what?
Lengths.
Yeah, right. But you could have negative money
How?
when you owe somebody. Yeah, thank you. Yeah. All right.
I did it.
Hang on. Let's see. Serenity, what's the biggest perfect square factor of 72? You might want to use your calculator for dividing 72, but remember, start with that. You want the biggest one. So start with the higher numbers probably. A lot of times there's more than one perfect square factor.
Oh, wait, I know.
All right, we're waiting for Serenity.
Hold on.
Hold on.
It's 36.
All right, times what?
2.
Okay, so rewrite it as what, Serenity?
36.
You mean what?
Square root.
Square root of 36 times,
Square root of 2.
there you go. And Serenity, what's the square root of 36? So 6 square roots of 2.
Yeah.
There you go. Hey, Hannah, F there. What's the biggest perfect square factor of 500? Hmm? No? Do you have your list of perfect squares there? The one numbers you wrote on that page? Find the biggest one that goes evenly into 500. Everyone be quiet. Is 20 a perfect square?
I don't know what you mean by
You know the numbers you wrote on the line?
it. Yes.
Those are the perfect squares.
Oh.
So which of those is the biggest one that goes into 500?
It's a.
Hmm.
I did not answer.
Shut your pothole. Is it like 110 square?
Oh, does 100 go into 500? Is it a perfect square?
Yeah.
How many times does 100 go into 500? So I can rewrite 500 as what times what? 100 times with the 2 square roots. So it'll be negative square root of what? Hannah? 100 times what, Hannah? Not 5. The square root of 5. There you go. That negative sign just sits there. Hey, Hannah, what's the square root of 100? What was the number you squared to get it? 10. So negative 10 square roots of 5. You kind of getting the idea now?
Yeah, no, not good. Is that all we're doing? Yeah, no,
And
yeah.
the problem set.
Oh,
Tomorrow. Yeah?
you're gonna kill me.
Mm-hmm. Probably.
What? She could have died.